Hello everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is diagonal traverse 2 and it is going to be a medium level problem. So I would say that after a very long time, I encountered a slightly interesting problem on Leetcode, and only because it has a very small observation that you need to make in order to solve this problem correctly. So the problem says that we have been given a 2D integer array nums and we have to return all the elements in the diagonal order as shown in the images. So we are just going to directly discuss sample number 2, example 2, just because this example lets us know that the arrays itself can be of different sizes, or the vector itself can be of different sizes, right? So this is what we want at this particular problem. So you see, these are the lines or the diagonals that that represent the order in which we have to print the elements. Now, there is one very interesting thing about this problem, that the first array that you see here, this one is of 5 size, right? Now this is going to be of 2 size, this is going to be of 1 size. Let me just also write it 5, 2, 1, and this is going to be of 3 size. This is going to be of 5 size again, right? So you cannot predetermine what will be the values or what will be the positions that are going to be stored in my final array. So let me just tell you this once more. So let's say if I have an array of a fixed size means n into n, right? So let's say this is position 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So you will always know that 0 will come first, then 3, 1, then 6, 4, 2, then 7, 5, and then 8. You always know this for a matter of fact. But now what if some of the elements are removed in between, right? So for example 4 and 5 are removed, so 4 and 5 should be removed from here as well, right? So you, in this particular case, in this particular problem, you don't know this particular thing, which elements were removed in between, right? Now a simple approach, again a very simple approach, would be to traverse through the array. So let's say this is 0, this is 1, this is 2, right? So what you would do is you will start from the 0th index and go till the nth index, and for each index you're going to initialize your column with 0. So I is going to be these rows and j is going to be the column. So let's say you are at index 2, right? So I is equals to 2 and j is equals to 0. So you write the element. Now you increment j by 1 and decrement I by 1, right? So this is 1, 1. Now you come to the index 1, 1. You see that there is no element present. Again, you decrement I by 1 and increment j by 1, right? So you come to this particular index and then write 2, right? So this could also be one of the way of solving the problems. But the time complexity of this particular approach would be O of n square, and that is not desirable here because the size of num's length is equals to 10 raised to power 5. So if n is 10 raised to power 5, we cannot form a n square approach. So we will have to somehow optimize this particular approach, and then we see this particular thing that says that sum of nums of I length is less than equals to 10 raised to power 5 as well. That means the size of the final array or the answer array is always going to be less than 10 raised to power 5, or that means all the blocks that are present in the given problem will always be less than 10 raised to power 5. So the number of rows can be up to 10 raised to power 5, but the total number of blocks that we have here is also up to 10 raised to power 5 as well, right? So we cannot form an algorithm which runs in O of n square with respect to the number of rows. This is for sure. Now again, when I show you this particular example, there is a very interesting thing that you will also observe, and that thing is the sum of the values of I and j is always constant in this particular case. So in this example that I took, it was always equals to 2, right? Because if we are increasing one value, we are decrementing the other value, right? And both of the changes are going to take place by a matter of 1, right? So if I am adding 1 and I am decrementing 1, the change is going to be 0. That means the summation is always going to be constant. This leads me to the conclusion that all the elements that are going to be the part of the same diagonal will always have the summation of I and j equals to a constant, right? And you can also verify this particular thing here. If I show you, so let me just write this rows and columns. So this is 0, 1, 2, 3 and 4. So this is 0, 1, 2, 3 and 4, right? So let's say this is 0 and this is going to be 1 plus 1 2, this is going to be 2 plus 2 4, 3 plus 3 6 and 4 plus 4 8, and this is going to be 4 plus 1 5, and this is going to be 4 4 5 6 and 4 5 6 7, 4 and 4 8, right? Now you take any diagonal, let's say this particular diagonal, and take any square on it, you will always observe that the summation is always going to be 4. So let's just take, so this is actually 2, sorry, so this is 2 and this is 3, this is my bad, so this is 4, right? So I wrote it incorrectly, 1 2 3 and 4. So the thing is, this row was 1 and this column was 0. I for some reason took this particular part and this particular part, but that is totally incorrect. You will have to take for any cell the current row and the current column. So for this particular diagonal that we took, the sum should be equal to 2, right? So because this 2 and 0 is 2 plus 0 2, then we have this particular cell on this diagonal, that is 1 plus 1, and then we have this particular cell on this diagonal, that is 0 plus 2, right? So for any cell you have to take the current column and the current row or the current I and j indexes. Now let us take one more example. So this is 3 plus 0 equals to 3 and this is 0 plus 3 equals to 3, right? So you will have to take care of this thing, that for any cell you take the current row and the current column. Now I took it incorrectly because I took this particular row and this particular column, that was incorrect. But if you all always observe, the sum of the rows and the columns for any particular cell on a single diagonal is always going to be a constant value. So once we know this, what can be the maximum value of that sum? We know that the maximum value of that sum can be 10 raised to the power 5. That has been already given to us in the problem itself. Summation of nums of I dot length is always up to 10 raised to the power 5. Nums of I dot length, what does that mean? So nums of I dot length means total number of blocks or the total number of diagonals that we can have. So this is the maximum upper limit that we can have in our problem, and this is the maximum upper limit on the value of I plus j. So what we can essentially do is we can have a traversal for all the elements in this particular array, and let's say we have an array denoting the positions. So we will push back the current element in positions of I plus j, and this is like this. So nums of I and nums of j. So I'm going to traverse through this nums array and I'm going to push back this particular element, current element, into I plus j position of this particular position vector, right? So that means this position vector is going to store all the elements in the I plus jth diagonal, right? Now once we have all the elements like this, we can print, we know that the elements of the 0th diagonal are written first, then the elements of the first diagonal, then the elements of the second diagonal, then the elements of the third diagonal, and so on. We know this order, so we can easily print all the elements. Now one more very important thing that you need to note is that if you traverse from starting to end, that is in this particular direction, right? So from top to bottom and left to right, you will always observe that the elements at the top are the elements which come at the last in the diagonal. So for example, if you take this 2 diagonal, right, this particular diagonal, so the element at the top was expected to be the last element. So if we push this element first, if we maintain the correct order, then this element will be in the last. So let's say we have position of 2, right? So what will be the elements in position of 2? These are going to be 3, 7 and 8. So 8 should be the first element. So I'll have to take elements from the back while pushing it into my final answer. So this is the last thing that I wanted to you to know. So let me just show you my summation. I got one runtime error here because I took the limits incorrectly. I'll show you that also so that you don't make the same mistake. So you see here I've taken the limit to be 10 raised to the power 5 because that is the maximum upper limit. But here I took it to be n plus 10, that is totally incorrect, right? And the rest of the things are same. So what you essentially have to do is, let me just copy this code and show you here only. So you see what I've done is I've taken a position vector. So this is going to be a double dimensional vector. Now this position vector is going to tell me, let me just write it also. Position vector tells me the elements at the ith diagonal. right? This is what I'm trying to store in the position vector. Now I also have an answer vector. I'm just going to traverse through the array in the whole nums array, and at position I plus a I'm going to push back the current element nums ij. Now I'm just going to go through all the diagonals, since I already know that the elements of the 0th diagonal occur first, then the elements of the 1 diagonal, and then the elements of the 2nd diagonal, and so on. I'm going to traverse through all the diagonals in this order, right? And I have like implemented this part this way. So I already told you that we need to reverse the array elements or the diagonal elements, right? So one way could be you could reverse the vector and then store it in the forward order. But what I did was I'm just pushing back the last element into my answer vector and just like popping back the last element in the current position vector. So this is same as, let's say, so I told you that 3, 7 and 8, you want 8 to be first and then 7 and then 3. So one way could be you could reverse this array and write the elements in forward order. The other way is you always know what is the last element. So you take this and remove it. Then you take the last element and remove it. Then you take the last element and remove it. Right. So this is exactly what I have done. Because this operation post dot pop back is going to be O of 1 operation. So this is equally fine as taking the array and reversing it, right? And even reversing it would add the extra complexity. This would not, right? So what you could do is I'm just maintaining a while loop. While this current vector is greater than 0, the size is greater than 0. I'm just going to take the last element and pop it back from the current vector. So at the end, I can just return my answer vector, and that is going to have my final solution. So this was it for this particular video. I hope that you guys were able to understand the solution, and in case you did, then definitely consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that was it for today. Till the next video drops, keep coding, stay safe, bye bye.